A DC machine is an electromechanical energy alteration device. The working principle of a DC machine is when electric current flows through a coil within a magnetic field, and then the magnetic force generates a torque which rotates the DC motor. The DC machines are classified into two types such as DC generator as well as DC motor. The main function of the DC generator is to convert mechanical power to DC electrical power, whereas a DC motor converts DC power to mechanical power. The AC motor is frequently used in the industrial applications for altering electrical energy to mechanical energy. However, a DC motor is applicable where the good speed regulation and ample range of speeds are necessary, like in electric transaction systems. Construction of DC machine. The construction of DC machine can be done using some of the essential parts like yoke, pole core and pole shoes, pole coil and field coil, armature core, armature winding otherwise conductor, commutator, brushes and bearings. Some of the parts of the DC machine is discussed below. Yoke. Another name of a yoke is the frame. The main function of the yoke in the machine is to offer mechanical support intended for poles and protects the entire machine from the moisture, dust, etc. The materials used in the yoke are designed with cast iron, cast steel otherwise rolled steel. Pole and pole core. The pole of the DC machine is an electromagnet and the field winding is winding among pole. Whenever field winding is energized, then the pole gives magnetic flux. The materials used for this are cast steel, cast iron otherwise pole core. It can be built with the annealed steel laminations for reducing the power drop because of the eddy currents. Pole shoe. Pole shoe in DC machine is an extensive part as well as enlarge the region of the pole. Because of this region, flux can be spread out within the air gap as well as extra flux can be passed through the airspace toward armature. The materials used to build pole shoe is cast iron otherwise cast steel, and also used annealed steel lamination to reduce the loss of power because of eddy currents. Field windings. In this, the windings are wounded in the region of pole core and named as field coil. Whenever current is supplied through field winding, then it electromagnetics the poles which generate required flux. The material used for field windings is copper. Armature core. Armature core includes the huge number of slots within its edge. Armature conductor is located in these slots. It provides the low reluctance path toward the flux generated with field winding. The materials used in this core are permeability low reluctance materials like iron otherwise cast. The lamination is used to decrease the loss because of the eddy current. Armature winding. The armature winding can be formed by interconnecting the armature conductor. Whenever an armature winding is turned with the help of prime mover, then the voltage, as well as magnetic flux, gets induced within it. This winding is allied to an exterior circuit. The materials used for this winding are conducting material like copper. Commutator. The main function of the commutator in the DC machine is to collect the current from the armature conductor as well as supplies the current to the load using brushes. And also provides unidirectional torque for DC motor. The commutator can be built with a huge number of segments in the edge form of hard-drawn copper. The segments in the commutator are protected from thin mica layer. Brushes. Brushes in the DC machine gather the current from commutator and supplies it to exterior load. Brushes wear with time to inspect frequently. The materials used in brushes are graphite otherwise carbon which is in rectangular form.